Welcome to the Slop Temple. We pray this video helps.
This special microchip uses 16 pins and requires careful power selection. It supports 2 supply rails, 3V and 8V, depending on your design. The device contains 32 kilobytes of flash memory for your firmware storage. It communicates over SBI and I2C serial protocols for flexible integration. A dedicated hardware reset pin simplifies recovery during testing. The standard header pitch is 254 mm for breadboard compatibility. Add 1 mic. Begin by connecting VCC to either 3V or 8V for your chosen mode. Always tie the chip ground firmly to your system ground plane. Use a 10 kilo pull-up resistor on the reset line to prevent spurious resets. If your host uses different logic levels, add a level shifter between the interfaces. Mount a 2.54 mm header for easy connections to breadboards. Place 1 microfarad capacitor directly across VCC and G&D for decoupling and noise reduction. Program the microchip using a USB to SBI adapter set to 1 megabit per second. Configure the adapter for 3.3 volt logic levels to match the chip. Begin with a safe erase sequence before writing new firmware to avoid corruption. Upload the firmware, and then verify integrity using a checksum comparison for reliability. After programming, allow 5 seconds for the internal bootloader to start and initialize peripherals. Monitor serial or SBI responses during testing to confirm correct operation and handle errors.
Thanks for watching. Consider subscribing if we helped you.